Water itself is quite a mysterious and powerful substance. Given enough time, it can erode steel and rock. It is composed of hydrogen and oxygen, two of the most reactive elements on Earth. Science has also known for over 200 years how to extract hydrogen and oxygen gas from water through the process of electrolysis. It was from this field of electrochemistry and not nuclear physics that there emerged a revolutionary idea of a new kind of fire from water. In the 1980s, Fleischmann and Pons used their own money to conduct experiments for 5 years. They passed a current through an electrochemical cell containing heavy water, or deuterium oxide. One of the electrodes, the negatively charged cathode, was made of the precious metal palladium. The electrical current separated individual deuterium nuclei, or deuterons, from the heavy water and forced them to pack tightly into the palladium cathode. What happened next inside the palladium at the atomic level remains a mystery and became the subject of intense debate. Whether it was actual nuclear fusion or some other as yet unknown phenomenon, the result produced far more excess heat energy than any known chemical reaction. Why is such a phenomenon so astonishing? Why did it provoke such outrage in the physics community? To most classically trained physicists, the concept of low-level nuclear reactions producing significant heat energy was inconceivable. The nuclei of atoms are all positively charged and naturally repel one another. They don't want to come together, to fuse, except at millions of degrees. And when they do, deadly radiation is released. When Fleischmann and Pons claimed that they had created nuclear reactions at room temperature, university and government laboratories around the world immediately set out to replicate the experiment, which, superficially, looked simple. Some reported similar anomalous heat and nuclear byproducts such as tritium, low-level neutrons, and helium. Others at major universities such as MIT and Caltech claimed they had found nothing.
And what we see in our laboratory is no evidence for any unusual nuclear or chemical reactions.
Critics insisted that if nuclear reactions were occurring, Fleischmann and Pons should have been killed by the radiation. Grumbling from frustrated researchers grew louder as accusations of faulty measurements and sloppy techniques were leveled at the two electrochemists. University of Utah officials were chastised for their haste in publicizing the discovery through the media instead of the peer review process. The emerging data was being drowned out amidst the clamor over impropriety and accusations of outright fraud.
In conclusion, we have no evidence in our laboratory with any of our samples for fusion.
I'm very sorry that Professor Lewis has no information on the tritium levels. That is available, and is available in the correction list to the paper.
We know the foreground, we don't know the background. I would like to specifically...
The background, I beg your pardon, the background is available in the corrections to the paper.
That might be. I would like to specifically hear whether or not helium...
Don't
Could we go on to the questions, please?
Certainly.
It was a very unfortunate time to make such an announcement for various political reasons, really. The situation in the United States, the situation with regard to the program in hot fusion. So that was against it, but also, of course, was the fact that we were not ready to make such an announcement.
In April 1989, the U.S. Department of Energy convened a panel led by Dr. John Huizenga, an early cold fusion critic.
We wrote a very negative report and concluded that the results that were being presented to us were contrary to everything we had found out about nuclear physics over the last 50 years.
Editor John Maddox of the prestigious journal Nature nailed the lid on the coffin.
I think that, broadly speaking, it's dead. And it'll remain dead for a long, long time.
And of course, we didn't call it cold fusion at all. That was a term which was wished on us, but we never called it that. We felt the processes had to be nuclear to account for the high levels of the energy per atom.
Earlier in this century, a very distinguished chemist by the name of Irving Langmuir defined pathological science as the science of things that aren't true. And I have labeled my book, Cold Fusion, The Scientific Fiasco of the Century, simply because there's no experimental evidence at this point that any nuclear reaction products have been formed. Therefore, the claim that cold fusion is a nuclear reaction process without a commensurate amount of nuclear reaction products is simply pathological science.
The criticism of pathological science is one which has quite frequently been leveled at unusual investigations, which admittedly sometimes are at fault. However, there is also the situation that people will criticize a field long after they should really have given up. And that is pathological criticism. They just get trapped in a situation. They have made a criticism. They have to maintain that criticism against all the evidence.
Cold fusion violates most of what I was taught in nuclear chemistry. And that's true of most people in the field. So you have to have some very persuasive evidence for its existence. That evidence was not persuasive. It was very indicative. It was the kind of evidence that normal people would use to go the next step. But it wasn't the kind of evidence that would convert somebody who was basically uncertain as to the reality of the phenomena.
The idea that two chemists could be doing this on a tabletop really sounded almost Alice in Wonderlandish, I must say. So I think our reaction was not unlike that of other physicists who thought, on the one hand, gee, that'd be marvelous if they're doing it, and then on the other hand, my God, chemists doing it for probably pennies compared to what physicists have taken from the public coffer over the last 40 years in the order of $40 billion to do hot fusion. So the nuclear physics community said, well, you know, the nuclear physics of this is looking very strange. It doesn't seem to be right. Where are the neutrons? Where are the gamma rays? And eventually, I think because of this bad nuclear physics, and because of the fact that people were having difficulty reproducing this, the physicists threw out the good baby, which was the excess heat effect, along with the bad nuclear interpretation bathwater. That was very unfortunate.
At SRI International in Menlo Park, California, Dr. Michael McCubry was one of the first scientists to replicate the cold fusion effect.
Fortuitous or not, in the first experiment that we ran some 3 or 4 months after the initial announcement, we saw some evidence of excess heat, which has really sustained me ever since. Having seen the effect with my own eyes, the claims from a few that this is impossible, inconsistent with all known laws of nuclear physics, these suggestions are in fact irrelevant. There is no theoretical objection to cold fusion. It's just unlikely given our experience with hot fusion.